Hi folks, in this video we're going to talk about FizzBuzz. The focus is not FizzBuzz per se. There's lots of crazy videos on FizzBuzz that go into way too much depth on FizzBuzz. What we're using FizzBuzz for here is a platform for discussing conditionals. In particular, the difference between the if and else if, if, elif, else type imperative programming language conditional construct that we'd find in a language like Python, and comparing that with the case statement and function head matching in Erlang that we use to decide what code branch to execute in Erlang. So this is more or less matching versus Boolean checks. And you'll see that in Erlang you actually kind of mix Boolean checks with matching quite regularly. And Boolean checks are actually kind of like matching in Erlang anyway, underneath. So, if you're not familiar with FizzBuzz, FizzBuzz is it's like a really simple kids game that, kids are like, I guess, made to play in school. They don't like play it on the playground because it's fun. It's just a simple math thing where you count from, you just like start at 1 and you start counting up. And anytime you hit a number that is a multiple of 3, you say fizz. And anytime you hit a number that's a multiple of 5, you say buzz. Anytime you hit a multiple of both, you say FizzBuzz. So counting up, you'd go 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, buzz, 11, fizz, 13, 14, FizzBuzz, 16, and so on. So we're gonna, check. We'll check first. I've written FizzBuzz in Python. Here we'll make it go to 16, and then I've written FizzBuzz in Erlang 3 different ways, so we can see different ways to do conditionals. And we'll just check real quick whether or not. Yeah. So these all work as expected. Okay. So let's open these up and see what's inside. You'll notice these programs are almost identical in size. The Erlang one's 19 lines. We could eliminate a bunch of them if we really wanted to, but the source code is for humans. The byte code and binary code is for computers. So, it's okay to keep things a little bit verbose. Especially if it makes it more readable. That's a worthy goal. So, if you're not familiar with Python, what's happening here? Everyone knows what a hashbang is, right? It tells the system how to run the thing. So Python's going to interpret this for us. We're importing system so that we can get the command line argument out. We're declaring a variable, which we didn't really need to do in Python, but we're going to go ahead and declare one here so we can know what we're updating as we go through. Count. We're getting the first argument off the command line. We're converting it to an integer, and we are putting it into the label out. So 4 is Python's loop construct, which exists in most imperative languages. This is an iterator-based style of for loop, so it's not quite like the C, the C one where you've got like your temporary initialized iterator value, a test, and an increment at the end. It's not quite like that. In this one, you like give it a list or something that can yield a next value, and you just loop over whatever values you're getting out of it. So for I in range is a built-in function in Python that gives you it's like list sequence. If you give it like 1 to 10, it'll give you back actually a list 1 to 9. It won't give you 10. The reason for that is that the singularity version of range starts at 0. So, and Python uses 0-based indexing. So, if you say I want 10 things, you're actually getting 0 through 9 things instead of 1 through 10 things. That's the reason that range in Python is exclusive. So we have to actually add 1 to count because it's not going to do the last value. So this was 16 when I just ran it. This became 16. This became 17, and then range returned back 1 through 16 because it's not going to give us that last value. So that's why this is here. If you're not into Python, then don't be too confused by that. And here's the part that we want to look at. How do we do conditionals? How do we choose what to put into out? Now, by the definition of FizzBuzz, if it's a multiple of both 3 and 5, this is the modulo operator in Python. What modulo means is you're getting the remainder of division. So 7 divided by 3 is 2 remainder 1. If we do 7 modulo 3, the return value will be just the 1. We're only getting the remainder back. So to see if something is a multiple of something else, you can do modulo something by something else and see if that's a multiple of the something else. So I modulo 3, if it equals 0, and if modulo 5 is also 0, then we know that we've got a multiple of both 3 and 5, and out should equal FizzBuzz. Else, if in like languages like C where you don't have semantic white space, you can just write else space if and then go on with your next clause. Python has semantic white space, so they actually had to make a joined keyword elif so that you don't have to jump down a new if clause each time. Otherwise, you'd have this like giant, a big slope of ifs if you had a lot of possible conditions you're going to check through in a string or in a stream. So elif I is a multiple of 3 fizz, else if I is a multiple of 5 buzz, else if none of this is true, then we just want the string value of that integer and then we're going to print it. And since we're in the indentation here, we're going to jump back up to the top of this and go with the next number that range gave us and do the same thing. So we're just going to rip through these numbers real quick, and then that's the end of the program. It's done doing anything. Over on the Erlang side, we're using an eScript, which is quite different from doing an Erlang like an OTP application. You can see examples of OTP applications that I do in previous videos. The Telnet chat server example that I did, the GUI examples that I've done, those things are all Erlang applications that are started up differently. And some of those programs have like lots of different processes running, especially chat servers. You could, like the chat server code that I demonstrated, it was really simple code. That actually could handle 100,000 concurrent users quite easily, which is that's a lot of processes. Here we're only running a single process. eScript will get us an execution environment, and it'll just run our code by calling main1, main with a single argument, and that argument is going to be the command line arguments as a list of strings. And remember, strings in Erlang are lists of character values. So you can use list operations on strings, which is really handy. We'll actually see an example of that at the end of this. So we should be getting only one argument. And if this gets more than one argument, it's going to crash. So we don't care because this is FizzBuzz. Who cares? So we get count as a string. We're going to convert that from a list to an integer, and we're calling FizzBuzz 1 to whatever the count was, just like we did over here. So you'll notice there's two FizzBuzzes. There's this FizzBuzz, and then there's this FizzBuzz. That's two different function clauses. And we have to pick which one we're going to run each time we iterate. The way we pick is we do a Boolean comparison using this right here. This is called a guard. So at the end of a function, you'll get a guard, and you declare a guard by saying when. So do this FizzBuzz when in is less than or equal to count. So we did 16 earlier. This was the string 16. This becomes the integer 16. Then we say, well, as long as in is less than or equal to 16. And remember, we started with 1. So if 1's less than 16, do this, which was true the first time through. Now, you may notice that we don't have a for There's no loop construct here because there are no looping constructs in Erlang. The way that we do loops in Erlang is we write them ourselves by using recursion. And all recursion means is a function calling itself again. So you're passing control back up to the top. And you need to do that at the very last step, because if you do that as the last step, it will eliminate the call stack, and it's an optimization to eliminate the call stack, which internally that kind of looks like a go-to. You just keep whatever values you've got in place or set up there, and you pass control back to the top. So we don't need a loop construct. We just need to, as the last step of whatever we're doing, if we want to loop again, call whatever the thing is we want to have happen again, which is so simple to teach kids, and it's so hard to teach adults that have any programming experience for some reason. I don't know why it's so hard to teach adults recursion. I shouldn't say adults. I mean, people with programming experience using for loops typically have like a really hard time comprehending how this is even possible to do a loop this way, because it's just not something you see in imperative languages usually. Anyway, so FizzBuzz in count lap. Okay, we're using count as our test. If this is not true, if in is like 17 or above, this is the clause that we would go to, and we're not even going to try to assign in or count to anything because we don't care. We're going to return the atom OK, and OK is actually going to come back up here, right? But it's going to go out into space. No one's ever going to listen to it because the program's going to terminate, and that's it. We could actually put exit 0 here, and that would be fine too. What exit 0 inside of an eScript would do is just give the return value 0 back to the system, which is kind of the proper Unixy way to conclude things. I believe that if you just return like an atom or a garbage value, if you don't crash anywhere, it'll do the same thing anyway. Like the runtime will do that for you anyway. So we don't care. We're just going to do OK, and that's fine. So there's two labels here. I say labels, they're variables, but the difference between a variable and a label in Erlang is kind of arbitrary, because Erlang has single assignment. You notice that we don't declare, there's no global out up here like we have in this one, because there are no global variables in Erlang. And you can't, after you declare a variable, you can't reassign it, because the equals sign in Erlang is three things. It's assignment, to declare a label like we're doing right here. It is assertion that something is true or something matches, and if it doesn't match, we're going to crash. And it's also a way to do a single match where we can assign within a match. And that's like if you're picking apart a value, if you have a tuple value, and you know the thing that you're looking at is a tuple, or maybe you get a tuple as a return value, and you only want like one part of it, you can use equals to break it open, match on the shape of the data, and then create a new variable name or a new label inside of that, and then carry that value on forward. So equals is three things in Erlang, and none of them are reassignment. There is no reassignment. The way that you reassign a value is by entering a new function context. So the scope, a variable is true until you re-enter a function's context. And that could be a lambda, an anonymous function, or it could be inside of a list comprehension or something. But scoping is always inside of a function. Function entry gives you a chance to reassign things, but never while you're inside of the body of a function can you reassign. So we only create out one time. We don't reassign it. Out gets printed out here to standard out. Now, how do we determine what out should be? Fizz is the Boolean result of a test whether the remainder of division by 3 is 0, and buzz is the Boolean result of a comparison between 0 and the remainder of division by 5, which is exactly what we have over here, right? We've got these two tests. Here we're just going to do each test once, assign the value, and then we're going to enter a case. Now a case statement is where you can match on the shape of a data. You can match on the shape and content of data. So FizzBuzz we're making a tuple of fizz and buzz together into a single tuple. We're going to match that tuple against a couple of possibilities that are just literals. So if fizz is false and buzz is false, convert that number to a string, and that's the value that we want for out. If fizz is true and buzz is false, return fizz. If fizz is false and buzz is true, return buzz. If fizz is true and buzz is true, return FizzBuzz. And then print that to out, then increment in by 1 and go back up to the top. So we're retaining the count value here specifically so we can do this comparison to decide when to stop. And that's just how this works. So inside of a case statement, we're going to any expression at all, we could call a function inside of here. Or we could put like this check could actually be right there. Like we could write these in line. But in case statements, it's kind of nice to have labels. The reason it's nice to have labels, this is FizzBuzz, it's super simple. What case gives you a chance to do is you can write a conditional check table, which can have an arbitrarily large number of possible elements to it. So FizzBuzz is simple, but if you're writing a game server that has to check the validity of every, you've got multiple players in the world and they're all fighting and they're healing each other and they're giving each other items and they've got trades going on and all these things are happening at the same time. Each time something happens from the client side, those clients could be, cheaters, right? They could have hacked up clients that let them do illegal things in the game. So the server has to calculate and check if every interaction is legal or not. Very often in game code, you'll have like a huge list. You'll have like 10 things. You'll have you'll have 10 checks that you got to go through. And a lot of times the checks are combined, like they're combined conditions that aren't just Boolean. You might have situations where a character is hot, normal, or cold, and thirsty or satisfied, or hungry or satisfied. And all three of those may combine in different ways to result in an impact on healing or sleeping or a time tick or a time update to decay or something like that. Some timer might be going on. The outcomes of all those calculations may be dependent on a matrix value of these conditionals. If you're doing that in an imperative situation where you have these ifs like that, you wind up creating multiple paths to similar values quite often. And that you can do this, but reading that code later and debugging it can be very confusing and frustrating. What often happens is when I'm writing a game server, I'll get a requirements list from whoever does the game design rules. A lot of times game rules will be written on a spreadsheet and you've got a header line that says like what different value possibilities there are, and it actually has a decision chart right below it. And I can just writing each check for each condition is really easy. Often it's just a direct assignment from a state variable. For simple things like being hungry or cold or whatever. That's usually just a direct assignment. So I can use a label, like I've got fizz and buzz here. I can assign labels as the return values from checks over the character state data, and any value that is a direct assignment is just whatever label, just make the label whatever the name of the condition in the game system is. Then the top line of case right here will be a long tuple that's exactly whatever the header line on that conditional spreadsheet was that the game rules guys give me. And then each line of that below, you basically just translate that to a case match. And that's it. You know exactly what to do after that. You know exactly where the code's going. And comparing it's really easy. Debugging it is basically checking if each line matches the line on the spreadsheet. So case gives you a really, really powerful tool to do really complicated matches in a very simple way, and it's quite efficient. and you can just hand all that off to the runtime instead of trying to write this maze of, sawtooth conditional code that's, you try to find. Someone comes up and they say, what happened? Wait, we have a problem when the character's wet and cold, but, he's not hungry. Something wrong is happening there. And you try to, okay, well, which branch of all this if, else, if, whatever, represents that? That's not so simple to find. Even writing a select statement or a case statement like in C, where you've only got like numeric matches, that can still be really hard to do. So this is a huge help if you're writing really complex decision-making code. So anyway, I'm kind of going on and on about decision tables here, but decision tables using a case statement, you can translate a decision table directly to a case statement, which is super cool. So let's look at, I said earlier that a case statement is an opportunity to create an arbitrary matching to create arbitrary matching locations within a function, like once you're already in a function head, or once you're already inside of a function clause. We can also do this we can do the same type of matching inside of a function head, which we see here using a guard, but we can do that directly with these Boolean values also. So FizzBuzz Erlang 2. Note how similar this is. FizzCheckBuzzCheckOut is being assigned to the result of something, and then IO format. We're doing the same thing here. We're just saying out is the result of saying check in. And we're going to pass fizz and buzz, the results of these tests, to fizz and buzz here. And then we're going to, print out to standard out just like we did before. So how's check defined? First argument is in, the integer value itself. If fizz and buzz are both false, then we need that value in so we can convert it to a string and pass it back. In every other case, though, we don't care what the value of in is because we're never going to need it. We just need to return FizzBuzz or FizzBuzz. So we use the underscore to say, I don't care what that value is. And then we're just matching exactly like we did over here. True, false, false, true, true, true. True, false, false, true, true, true. Exactly the same stuff. And these are just function head. We're just matching in the function head to pick which flavor of the function we want to run. And we're not caring about in. Now you might think this is a little ugly. We're just like tossing a variable away. It's true. It is a little bit ugly. I personally don't like the fewer throwaway variables I have in my code, usually the better. Having too many of these things happen is usually a code smell that I've got something that's kind of hard to understand further back up in the calling code somewhere. That's just me. It's a stylistic thing. Not that big of a deal. But it is something to keep in mind if you're writing, especially the more complex problem that you're tackling, the more complicated your code is going to necessarily be. And at some point, you'll hit this complexity barrier where you've got too much stuff going on that's too conflated together and you're forgetting what things are. So, the fewer underscores, the better. We could, we're also allowed to do this, of course. We use that as documentation. That's a fine thing to do. But, typically you shouldn't need to do that because you shouldn't have to have a whole bunch of underscore things that are totally unlabeled all over your code. So, again, case, we're just matching on the Booleans here. Same thing, function header, we're matching on the Booleans there. Now, there's a third way we can do this. Now, you remember this, when in is less than or equal to count. We can use that same technique to rewrite check without fizz and buzz ever existing. And some people really prefer this style. Fizz buzz in, count when in is blah. Okay. Out, check in. So when in is a multiple of 3 and also a multiple of 5, FizzBuzz. Else, if it's a multiple of 3, fizz. Else, if it's a multiple of 5, buzz. Else, none of that was true. We're just going to return the string value of n. You'll notice that this logic here is identical to this logic over here. This is how you would write the Python version over there. You can also do this inside of a case because you can use guards, the when keyword. You can use guards inside of case statements. So sometimes that's the right way to do things. I prefer the original one that was back with the case statement, but style, whatever. This is just another way to do it. Where you wind up getting a huge gain out of this is code like this. What you're looking at here, let your eyes adjust for a second. There's a function here called Parse, and it's got multiple cases. And what we're looking at is the decoding parser for a JSON string encoder decoder called ZJ. This code's from ZJ. So this is an Erlang language JSON parser. And when we get into the parse step, what this $ bracket does, let me show what $ does real quick. If I run so if we enter like an atom, true. If I enter an arbitrary atom, we just get atom back, right? So if I want to look at the value of the letter A, I can put a $, and 97 is lowercase a. If I want to see the value of the character, capital A, I can do that. So what we were seeing just up there was it was picking apart a list where that kind of a JSON list was coming in. So we were matching on the case that we had this. See, we just picked this apart. We're using the list. This is kind of like the a cons operation from Lisp. This is kind of like the cons syntax in Erlang. Is we're able to attach a head item onto a list. So, like I said earlier, strings in Erlang are lists of character values. So this character value gets appended to that, and the return value is this. Like these two are directly equivalent, and we can actually match on that in a function head, which gives us a really nice shortcut. We can say parse and just pick that first one off. We're like peeking at the first character saying, is this a bracket? Because if it's a bracket, I want to take I know that I'm in a JSON object now, and I want to parse the rest of that object, the rest of the JSON object, as an object. So we're going to call object rest. Now you notice that this happens inside of a case. The return value of calling object over the rest of that string is going to be an object like, okay, it worked, an object data value, and then an empty string, meaning there's nothing left. There's no more stuff to keep doing. If that's true, so we match on okay and we match on an empty string. If that's true, then actually we're done parsing and we're just going to return okay object, and that's going to roll up into the, whatever values were parsed before will get glommed on with this, but the whole parsing tree knows that it's done at this point. If it's not an empty string, it means we've got more stuff. We have there's more string after that. After the object that we parsed, that was done, but now we're on to the next JSON, data element in whatever JSON string we're parsing. So successful parsing, okay, the data value object, and more string to parse. So we're going to polish the object, meaning we're going to close it off, and then we're going to seek, which seek function in this gets us past all the white space garbage characters to the next meaningful thing. And then this is going to actually call parse again later. So reading this simply, I'm just explaining cases used in this way. Error, any other return value is an error, so we're just going to return that error back up, and it'll roll back up, and that's it. So what we're using the head matching for is if the input value, if the input argument, there's only one argument here, if the first letter is a bracket, then we're in an object. So parse that and loop again. If it's a square bracket, we're in an array. Parse it as an array and continue on. If it is a quote, parse it as a string. If it is now here we've actually got a guard, right? So this is mixed together. We're doing direct matching here over specific values. Then we're doing assign I as a as a variable that we're going to use temporarily here. When I is a minus sign or it is between the values 0 and 9, then that means that we're actually looking at a number that's represented in text, and we need to convert that to a real number, an integer or a float inside the system. So that's what this is here, is we're parsing a number. And again, the result of that, you notice these case clauses look similar. They look similar for a reason, of course. So, and I could have broken that out and done something else, but it doesn't. Repeating this little clause a couple of times doesn't bother me too much. So if we get true, now we're matching a full word, and then using the list append operator. This lets us match directly on true or false or null. We know that it should be the atom true, false, or undefined. And anything else would be an error in this particular part of parsing. And that's it. Like, that's the whole rule set for, first character peek on a new JSON object. The rest of the code leverages all this stuff. You see a parallel here to the way a lot of this works. And these are all, all the code works this way for these things. It's very, very simple to understand what's going on inside of this parser. Doing that with if-elif can, it works, but it's actually a little bit less readable, especially to a non-programmer. It becomes less readable, even if they know the rules, because their eyes, you just don't know where to go in the code to find anything. So anyway, this is, remember, in Erlang, we tend to use the case statement instead of using the if statement in other languages. Case along with function head matching and guards is our analog to if in other languages. And as you can see, case and head matching is like immensely flexible with whatever you might want to do. And once you get used to using it, you really start missing the ability to match stuff in other languages. And you really, it's frustrating to go back to a place where you only have Boolean checks ever. That's pretty frustrating. But, it's workable when you have to. There is, of course, an if statement in Erlang, but if is used in Erlang for numeric range checks, which are pretty similar to what we did earlier with, checking if, like this type of code where you've got multiple types of numeric checks. The difference is if you need an else clause in an Erlang if statement, that's usually, not always, but it's usually an indication that you shouldn't be using if. You should be able to completely define a range of every possibility that fits correctly, that some outcome within that if is definitely going to be true. So it's used usually to write very easy to read range checks, especially for numeric values in particular. And so if is a very different style in Erlang than other languages. So you're going to see case all the time, and you're going to see function head matching all the time, but you're not going to see if very often in Erlang. If in Erlang, if is one of those constructs that if you really need it and it really fits, you're going to know. But you should default to case in most cases. So that's all I got. I hope you guys have fun programming. If you have any Erlang questions or any topic that you'd like me to cover, just let me know. And that's it. So that's all I got for today. Go do things.